Check it out. Instant fireworks. That was a nichrome wire. And this is a bomb. Actually, it's not a bomb, it's something even better. This is a high power resistor. And these are quite expensive, but why is that? Everything has resistance, and basically a resistor could be any piece of wire like this one. For example, this wire has a resistance, this other wire has a different resistance, even this plastic wire could have a resistance. Yeah, I know this will be mega ohms, but it's still resistance. Actually, even our own skin has its own resistance. As you can see, I'm quite conductive. But why I've shown you the nichrome wire? Well, this is made out of an alloy of nickel and chromium. And this is commonly used in heating elements, heating devices such as your toaster, maybe a heating kettle or even space heaters. But it can also be used as a resistor. And it's also quite cheap. So I bought this very thick nichrome wire because I'll try to make my own high power resistor, and I want to use that to measure the output power of this generator that I've tried in a previous video. So guys, can I make it or not? Well, let's get started. What's up my friends, welcome back. This is a high power resistor and this cost me like $38. But if you check online and you look at a one of maybe 2000 watts, you can see that it could cost you from $70 up to $80. But why is that? Why is this so expensive? So let's analyze this commercial resistor first. We start with this ceramic tube. This is some kind of terracotta or some kind of ceramic. But why is that? Well, because this ceramic is a very good electrical insulator and also a very good thermal insulator, because this could get quite hot. Imagine for one of 2000 watts. You know what else could get quite hot? PCBWay offers. You see, I've been using PCBWay services for years. I've got more than 100 PCBs, and you know what I like best about them? The price. Because years back when I was in the university, it costed a lot to make a prototype for PCBs, but now with only $5 you can get 5 PCBs from PCBWay and you can make prototype after prototype till you get the best results. And for me as a maker, that's the best thing, because not all the time I get a perfect circuit. So making more iteration is the best thing for me for making a prototype. So if you also want to make your own PCBs, your own prototypes, go to PCBWay.com and use your Gerber files and select the option that you want to select for your PCBs, the thickness, the amount of layers from 2 up to I think 14 layers, which is amazing. Flexible PCBs, you can also get the stencil for SMD soldering or also the automatic assembly services, which is great. PCB will solder all the components for you and you will get your finished product. And by the way, you can merge together the PCB project with a 3D printing project or something made out of metal with CNC services, because PCBWay also has mold injected plastic, 3D printing with resin or FDM, and also metal sheet bending and CNC cutting and a lot more. So for more, check the link below for PCBWay.com. Now we can continue with our resistor. Then we have these two connectors, which are just some metal rings, and then we have this wire. But there's something interesting about this wire. As you can see, it starts here, it goes around, but then it turns back with another loop. And that's crucial for this kind of resistance. I've just told you that any wire could be a resistor, but if I wind it like this, it will become something else. So what could this be? Well, a winded wire like this one, it will have its own resistance, but it will also become an inductor because, well, it has loops, an inductor like this one. And you see, an inductor could store energy as a magnetic field, and also if you are using AC voltage, it will act as a filter, and we don't want that from a resistor. So what can we do? The first solution is to use a cable just like this one, a straight cable from one point to the other one. But if you want to have more resistance, you will have to use a lot of wire, and that will occupy a lot of space. That's why we want to wind it. So instead of just wind it like this, how about we just bend it in half and then we make the coil. And like that, as you can see, we would have two loops inside of the same coil. So we'll have a current that will go in one direction, creating one magnetic field, but then the same current will go backwards, creating another magnetic field, but in the opposite direction. So the magnetic fields will cancel each other out. So like that, this won't act as an inductor anymore. It will act as it is, just a piece of wire with its own resistance. So just by bending the wire like this, and then make the windings, Problem solved. For the commercial resistor, as you can see, they've used a flat wire instead of a round one. And also, being flat, it's also placed perpendicular to the dissipators, to the ceramic in this case. And that means that it will have a lot more area connecting with the exterior, so the heat dissipation will be a lot better because it's flat and it will withstand the same amount of power, but it can dissipate it faster because it has a lot more area. Also, they've made this some sort of zigzag, so it will be easier to place it like this, 90 degrees with the surface of the tube, and also to occupy more space, so having more length of wire. That's why they've made it like this. Before I make the homemade version using these basic elements, why would you need such a resistor? Well, in my case, I want to use it with this controller, and this is a charger for batteries using a wind turbine. Because the problem goes like this. What if the batteries are 100% fully charged, but there is a very strong wind outside? You can't stop the wind, can you? So that means that since the controller is not charging the batteries anymore, the wind turbine could accelerate at very high speeds because it has no load attached. That means that the wind turbine will get very fast and could vibrate or even get damaged. That means that we need to break it down. And in order to do that, we add an extra load. That's why I need this resistor to act as a load for my turbine. And since this motor could give up to maybe 300 watts, that's why I need a high power resistor to slow it down so it won't break. Another example that I wanted to give you is that if you remember, a few weeks ago I've made a teardown of a hoverboard and I wanted to measure the maximum power of this motor here. And I wanted to do that with my electronic load, which, if you remember, got burned out. So instead of using an electronic load, I want to use a real load. But this load here has a fixed value. You can't change the value between the input and the output. I want a variable resistor, but also of high power, in order to test the maximum power of this motor and be able to test for different values of the load. That's why I want to make my own resistor, which will be of high power and also variable. Okay, so let's make one. This is a nichrome wire. And the good thing about this material is that it has a bit higher resistance than, for example, the copper wire. That means that for the same value of resistance, the wire could be a little bit shorter, so it will occupy less space, but still it will have the same resistance. So look, I measured the resistance of this copper wire, and it will give me that value, 0.045. Now I measure the resistance of the nichrome wire with the same length, and even this nichrome wire is thicker, so it should have a lot less resistance. As you can see, the resistance is higher. It's 0.16, so it's like 3 times higher than the copper one. And remember, this is a thicker wire than the copper wire. So for the same length, or in this case the same area that it will occupy, we can have a lot more resistance. That's why we call this copper wire a conductor, and we tend to call the nichrome wire a resistor. They are both a resistor and a conductor at the same time, depends on how to use it. But there is something more about the nichrome wire. The other best thing about the nichrome wire is that it could also withstand more temperature than the copper wire, and it also tends to heat more than the copper wire. That's why we use it in heaters such as the toaster or maybe an electric kettle. So I want to dissipate as much power as possible for my project, maybe even up to 1000 watts. That's why I need the nichrome wire, to have high resistance and also to withstand the power and the heat. But this is also nichrome wire, but look how thin this is. If I were to use this for my high power resistor, look what will happen. That's why instead of that, I bought this nichrome wire of a thickness of 1 millimeter. And guess what? It cost only $2. My generator could create around 30 volts and is supposed to get up to 300 watts. So by Ohm's law, that means that we need a current of around 10 amps. With 30 volts and 10 amps, we can calculate a resistance of at least 3 ohms. So if those 6 centimeters of wire had a resistance of 0.1 ohms, for 3 ohms we need almost 2 meters of this wire. Now that we know what wire I will use, let's check the options for the support, which is also very important for the heat dissipation, because this can get quite hot and you don't want your resistor to burn out or catch on fire, right? For that I thought about 2 options. First, I want to copy the same option of the commercial one and use some sort of ceramic, because that is very cheap and also very basic. The other option that I have in mind is to use a copper tube to maybe insulate it so it won't make a short circuit, and even add a water-cooled system with this water pump and this air radiator. In that way it could dissipate a lot more heat faster, and that's for very high power. So we can test these options out. For the ceramic option I wanted to use something very cheap and easy to use. But I do know that the normal plaster that you use for your drywall will crack under a lot of heat. And I know that from another project, if you remember the smoke machine, that plaster cracked very fast. So someone told me that I should use the cement or plaster that you usually use to cover your small squares inside your bathroom, because that could withstand, it's a little bit more elastic and could withstand a lot more heat. So I've made that, I've made the paste, placed it into a mold because I wanted to give it a tubular shape, and then 2 days after, when it was dry, I tried to get it out, but as you can see, when I took the tube out, it turned into pieces. It just cracked. So now I think this piece here is too small for my resistor, because remember, I have to wind around 2 meters of that wire, go back and forth, and the wires can't touch each other because that will be a short circuit. So I need a lot more space. So I'm not sure if I can use this. But you could use any other type of insulating material, even a piece of wood. All depends on the power that you want to use. Actually, if you're not planning to use a lot of power, so this will get more than 40-50 degrees, you can just use the wire like this. Just wind it and that's it, in mid-air. So you don't need a support for that. But in my case, since this will dissipate a lot more power, I want to cool it down. So that's why I need some sort of base or some sort of support. For example, another good option would be to use glass, because glass is also a very good insulator for electricity and also for the heat. So you will take a tube like this one of glass and just wind your resistance on top of this, well, in this case, a glass bottle. So I'll just go and try the other option, because this is not a finished product. All I want to do is to make an experiment and have something to test the power of my motor. So I'll get the copper pipe. If you don't want to insulate it, you could just use maybe a glass pipe or even some sort of acrylic that could withstand high temperatures. If not, I'll take this material, this is some kind of cloth, I will put it on top of it, so I will insulate it from the wire, because copper is conductive, and if you touch the nichrome wire with the copper, it will be a short circuit. Once it's insulated, I add the copper wire, and then I have these fittings for the tube. This will be for a vinyl tube. I have these end bits. I'll put the end bits on, once I cut it to size, obviously. I'll put the end bits, and water will come from the water pump to the heat dissipation module, which has a fan. Then the water passes inside of the tube, getting all the heat, and it will dissipate that heat here with the fan. So the first thing that I will do is to measure the resistance of my nichrome wire till it gets to above 3 ohms, which is more or less what I need in order to test my motor. Depending on what you want to do, measure a different length, or even you can buy a thicker or a thinner wire, but have in mind that the thicker is the wire, it will withstand more power, but it will have less resistance, so more current it will pass. So if you want more power, you need thicker wire that will have less resistance, so you need a longer wire. Anyway, I'll measure it with my multimeter till I get more than 3 ohms, cut it to size, then we'll have to insulate this, because this is not like an enameled copper wire, so if I bend it in half, it will touch one with each other and create a short circuit. Then we'll put it on place of the tube, which will be insulated with this tape, and make our resistance. So I've measured it and cut it to size, and in my case it has almost 4 ohms, which is more than enough for me. So now we can use it. So because this is not like enameled copper wire, so it will have its own insulation, my idea is to just make one loop on one side, leave a lot of space in between the loops, and then insulate it here, and then make another loop without touching the wires. Maybe add some glue so it will stick in place. But first I will add this tape, which will insulate it from the copper tube. And also have in mind that this is not a very good heat transfer. You should use a different kind of cloth. Those type of cloths that you usually use with your heaters, your electric heaters. I don't have that material right now. I'll try to place a picture here if you want to use it. That will be a lot better, because it can transfer the heat and also withstand a lot of temperatures. Up to like 600 degrees. By the way, I just realized that by making a loop in one direction and the other direction, we can cancel the magnetic fields. But choosing a copper tube is the worst option that you could use, because since copper is conductive, it will conduct the magnetic field and will make the magnetic field even stronger. So in this case, using ceramic or plastic or acrylic or maybe glass, it will be the best option. But in this case, I will just use this copper tube, and hopefully widening the wire in one direction and then in the opposite direction, it will cancel the magnetic field, hopefully. I don't really know how long the tube should be, but I will insulate it all and then cut it to size. So now the entire copper tube is insulated, and we can wind our wire. I don't know if you can see, but I went into one direction, insulated here, and now I'm going backwards in the opposite direction and just placing the wire in between the other wires without touching, and that's the only kind of insulation I can do right now. Just wind it, wind it, wind it. So now I have my tube, I cut it to size and also removed the insulation on the tips because I wanted to add these caps like this. But I made two mistakes. The first one is that I added the insulation and the wire before soldering this to the copper. And in order to solder this, we need to add flux, we need to add the solder paste and also heat it a lot with a torch. So we can't do that because we will burn the insulation. And I will have to remove it and solder this and add it back, which I don't want. And the other problem is that the cap that I bought, which is made out of brass, this is almost as big as the tip that I bought for the plastic tube that will come from the water pump. So I can't really make a hole here and place it inside because it's very small. But fortunately, as you can see, this has a thread and is a little bit bigger than the tube, so I can thread it, but that will generate leaks. But since this won't be of high pressure, I'll add some Teflon to insulate the leaks, and also I have this Loctite, which is specially made for threads and is very, very good with gluing metals as well. In this case copper, and this is some type of alloy. So what I will do is to push this in, add the Loctite, and since we won't have too much pressure with the water pump, this will work quite well. So that's what I will do. Also, as you can see, this fitting has some sort of rubber washer, and that when I will press the thread, it will also insulate all the water inside. So I hope that we won't have any leak because this pump doesn't create a lot of pressure. Now that I think of, instead of using these fittings that will go to the rubber tube that will go to the pump, we can also just fit the tube inside and maybe glue that to the tube, and in that way we won't have any kind of leaks. So we can also do that. It's a lot easier. So just like that, I have my resistor. I know this is very basic, very crude. This is a homemade version, but it works for what I wanted. I want to use it. As you can see, I've made another one because I realized that this one reaches only 3 ohms, and with that, with my motor, I could reach 300 watts. But I want to make a graph going from like 100 watt up to 300 watts. So that's why I made a different one. But as you can see, even this is smaller. It has a lot more resistance because, as you can see, the winding is denser, and also it has 2 layers. So this one reaches 10 ohms. So with that I can go, I think, from 100 watts to 300 watts. But just like that, I have my resistors. But I've also told you that I want to be able to change the resistance of such a resistor in order to make my graph, because I want to make 100 watts, 120, 130, up to the maximum point. So how can we change the value of this resistance if the resistance is fixed to 3 ohms? Let me show you that. So look how easy it is to pass from a normal resistor to a potentiometer, in this case a variable resistor, with this homemade one. As you can see, this is the maximum value. So have in mind that the loop starts here, goes till the end, the loop will end here, and then will go back. So if instead of ending the loop here, what if I end it here? That means that this resistance here is lost. So if this is 3 ohms, this will be like 2.8, 2.7, 2.6, and so on. So all you have to do is to make some kind of slider. In this case, I will use this piece of wire. So if I touch the wires here, the loop will end here. So let me just touch them. As you can see, it dropped to 2.6. Now I touch them here, 2.1. Now I touch them here, 1.8. Now I touch them here, 1.2, and I can go down to 0 point something. So as you can see, just by sliding this wire, let me just slide it. I'm not sure if the multimeter is fast enough, but as you can see, I can increase the power up to the maximum of 2.8, I think it was 2.9 ohms. So that's how we can make it variable, just by making some sort of slider. So when I will be making tests, I will just join this with a wire, then join it here, then join it here, and increase the power of my motor. So guys, I hope that you now understand that any piece of wire could act as a resistor. Actually, if you remember, when I've made the full sine wave inverter, I used a shunt resistor, which is basically a resistor that could withstand a lot of current, but has a very stable low value of resistance. And I say very stable because when you buy a resistor, it could have a tolerance, and that means that, for example, it's of 10 ohms, it could be 10 ohms, maybe 11, maybe 9. so it's not very precise. But for a shunt resistor, which I'll try to place on the screen, which are very small, just a piece of metal, you need to exactly know the resistance between one point and the other point, for example 0.1 ohms, because we use those resistors to measure the current, so applying the Ohm's law. So if you know the voltage drop and you know the value of the resistance, you can calculate the current. So you need to precisely know the value of that resistor, because otherwise the calculations that you will make are not correct. So now you know that you could use any wire to make a resistor, but have in mind that the nichrome wire has a little bit more resistance than copper, for example, actually a lot more, it's almost double I think. And it also could withstand more temperature, because usually when you pass a lot of power through a wire, or a resistor in this case, it can get quite hot. That's why we use this material for heaters. So basically all you have to know in order to make your own resistor is to know how much power you will dissipate. So for that I will link below some calculators that are online, where they ask you the cross-section of the wire, if it's squared or round, so the diameter, the length of the wire, and the type of material that you are using. Copper wire, nichrome, and any other materials. For example, you could also use tungsten, which is what they use in those incandescent bulbs, the old ones. So you can get in that calculator, you can add your values, and the website will tell you how much power it can withstand and the temperature that it will reach, so you'll know if you will need water cooling or not. But basically I told you, you can just get the wire and use it as it is, as a resistor. I will add water in my pump, and as you can see this is a closed loop. The water will go from the pump to the radiator. This has a fan. It will cool it down, and then it will pass to the resistor, getting all that heat and getting back to the pump, once again to the heat dissipator, to the radiator, then to the resistor, and so on. I won't test it yet because I don't have the setup for the motor, because I still have to hook one motor to the other one, spin one with some kind of ESC, and then measure the output of the other motor. But that will be for a different video because I don't have time to make that now. So guys, I do understand that the resistor is a very basic component. But when you are talking about high power resistor, it could get a little bit more complex. You need to know what material you are using, the length, the width, how you dissipate the power, and so on. So I hope that now that you have seen what I've used here, you know more or less how to calculate your own resistor and how to make a homemade one, how to add some dissipation, maybe water dissipation in this case, or just a ceramic. But I still don't understand why this is so expensive. I mean, the ceramic here is very low cost. I mean, what could it worth? $1, and then the wire maybe $2 more, because this is a lot more thicker than mine and is flat. And that's it. I think the price goes up with the connectors that I have back there, and also because it weighs quite a lot, so shipping will be a lot higher, especially if they ship this from China. But even so, I think this is expensive because not of what it worth to make it, but because we don't get to make the price. The seller make the price, and since they don't sell too many of these, because I mean, how many people will use such a resistor, that makes that the price will go a little bit higher. Anyway, I hope now you know how to make a homemade one, and I really hope that you have learned something new and this video helped you. If so, consider giving me a like and comment below. Thanks again, and keep up you guys. Hey guys, so that was another project, and I hope that you like it. As you all know, to buy all these modules, a huge help from you is from Patreon. So if you want to support me, you can support me there, but also just commenting below, giving me a like, or sharing this video, it will also support my channel. So thank you very much to all my patrons and to you guys.